It's just a bit more testing of the maximum power point charge controller thing that I've been working on. And I think the main issue that I've been having in not getting enough current gain is the magnetics, because I got this microcontroller running a simple test program where it's just simply varying the duty cycle of the PWM drive signal for the buck converter, and that is working more or less as expected. And so I'm getting the potential differences that I am expecting given these given PWM drive frequencies, but or more or less there's a bit of difference. So I'm guessing the issue is principally in the magnetics. It's just either incorrect inductance or wrong core material, but again, this is stuff I don't really know how to design, so it's going to require a great deal more research before I can have something that's functioning ideally. And of course also these are less than ideal conditions for testing a maximum power point charge controller, because somewhat warm day, so my modules are fairly hot and the batteries are more or less fully charged, so the 10% current gain is really good under those circumstances. So it sort of functions, but kind of finicky. And these are the relative current. This is the photovoltaic array current, and this is the battery charge current. Now the photovoltaic charge current is typically about it's varying between about 6% and 10% higher, but thing is that I'd be expecting at least 10%, so performance is less than ideal. Now, of course, this meter also reads about 1% higher than that, so that is something that needs to be taken into account. Buck converter is sort of working, since it goes about 6% higher and then increases to about 10% higher as the current goes down. But actually, now it's staying at about 6%. It's kind of hard to do these calculations on the fly because it's very time varying. Now the thing is that the algorithm, if I increase the intensity, might show up better on camera. The algorithm, it's starting out with the duty cycle being almost 100%. Can't really easily measure it on this oscilloscope because it's analog, but it's but of course my digital oscilloscope displays too dim to show up in sunlight because it's only intended for indoor use. But see, it starts out with a duty cycle at nearly 100% and gradually backs off. The photovoltaic array current the potential is increasing during this time as I measured it, but the current gain isn't really improving. So my guess is just it's simply the magnetics aren't performing as well as they should be. So that's going to require a great deal of experimentation just to determine proper inductor value, proper core material, and it's already spent over 130 hours working on this project. So yeah, but so it kind of works, but it's not there yet. Yeah, so it's trying to calculate it, but the thing is that the algorithm is expecting the buck converter to be functioning ideally, and it's not. So that's going to require a great deal more experimentation. I tried this is a 43 material core. I tried a 77 material core, and that was about in the neighborhood of 700 and change microhenries. This particular one is about 170, but I'm getting about the same performance. I don't know if the inductance I need is somewhere between the two or not, or but yeah, it's taken, so it's sort of working, but not quite. And of course I need my oscilloscope, battery bank, and 1 PV module, 2 PV modules, and 2 more PV modules over there, so it's a lot of test equipment for this. Hey.